Hello guys, I am Hitesh Tripathi. I am your instructor via Nutanix School, and today in day 5 of this playlist, that is data structures and algorithms, we will cover what is bubble sort, insertion sort and selection sort. Okay, so in previous video till now we have already learned binary search and searching algorithms and their time complexity, and then different type of sorting algorithms, and also we have seen everything about them in brief. So today we are going to dig deep in these three sorting algorithms, that is bubble, insertion and selection sort, and then we will also see their implementations and everything about them. But before that, let's see what Nutanix School is. So basically Nutanix School is an e-learning platform in which they are training you for being a full stack developer, and in this program they will teach you everything like different core subjects like front end and back end development and programming languages like Java, Python, everything you need to be a full stack developer. And not only this, then they will also get you placed in these companies like Snapdeal, Curefit, Xiaomi, Lenskart and many more like that. And they have tie up with almost 300 companies of India, so it is also a good thing. Most amazing thing about this is that they have a pay after placement program under which you don't need to pay even a single penny until and unless you get placed in any of these companies. And the minimum CTC which they are providing is 5 lakh. Okay, so it is also a good thing. So you just need to come to newtonschool.co and check their pay after placement program. Now next thing is they have a new initiative, that is Launchpad, under which you can start learning for free. They have different courses like courses for different core subjects, different programming languages, core subjects in Hindi and English both language, and competitive programming and everything they have for free. So you can just come to their website newtonschool.co under Launchpad initiative. You can sign up for free and you can start learning, and you can also get certificates in completion of courses, and you can also start quizzes here. You can practice coding here, like you have IDE built in this website only, so you don't need to go anywhere else. You can just start everything from here from scratch. Okay, so just come to newtonschool.co and check their both programs, that is pay after placement and Launchpad initiative, and get the most out of it. Now one thing more, that YouTube channel Code Kitchen Nutanix School, you can subscribe this channel. In this channel I have taught you firstly C++ tutorials, and in this playlist I have taught you everything about C++ and then STL in C++. Okay, all the important STLs. Now we are heading towards data structures, and in this we will be seeing everything about data structures and algorithms, different data structures and containers, everything. Fine. So now just begin with our today's video, and in that we are going to see three algorithms and their implementations, that is bubble sort, insertion sort and selection sort. Okay, so let me tell you first thing, that these three sorting algorithms are important but not that much. Why? Because their time complexity is obviously n square. I have already told you this in previous video. They have a time complexity of n square, where n is the size of container. Okay, and since time we have algorithms of lesser time complexity, that is n log n, so we don't generally use these three algorithms. Okay, bubble sort, insertion sort and selection sort. But obviously we need to know about them, because in some interviews or somewhere someone can ask us like tell me about bubble sort, insertion or selection. That's why we learned about them. Okay, and after that only we can we can enhance their performance, and we will head towards algorithms of n log n time complexity. Okay, so that's why let's start with bubble sort. Since we know we have time complexity of O of n square about bubble sort, and I have told you in brief that in bubble sort what we simply do is, suppose we have a bucket of water, and in that bucket what happens simply is bubbles with smaller bubbles comes to upper section. Okay, and below that we have bigger bubbles, and at the bottom we have some water, okay, lesser number of bubbles at the bottom. Okay, so all the bubbles comes to upper part of the bucket, and we have bubbles in increasing size. Okay, so same thing we do in bubble sort, and here is the pseudo code of bubble sort. What we, let me explain you this code. Okay, now we will suppose we will start for every, suppose we have this container. Okay, fine. And what we will simply do is we will find out, we will iterate in this whole array. Okay, suppose we have some bubbles in it, and we will iterate in this whole array, and for every pair, suppose I and I plus 1, we will compare them, and if these pairs are arranged in correct order, that is this pair at ith index is less than I plus 1th index, then we will not do anything. Okay, otherwise what we will do is we will swap them. Swap means I will place ith element at I plus 1th position and this I plus 1th element at ith position. By doing this, what I am doing is I am correcting order of any two elements, okay, that are placed adjacent to each other. Okay, now suppose some lesser element came here and some bigger element came here. Now we will again do the same operation for these two operations. Okay, and then suppose this ith element is bigger than this element also, so we will swap them again. So in one whole iteration, what we will be having is we will be having biggest element of the container at the last position. Okay, so this is the motive. Like in one whole traversal, what we do is we bring biggest element of the container at its correct position, and then we will do same thing for this size of container. Like this element is already at its correct place. Okay, so we will do the same thing for this much container, and then in this size of container we will select the biggest, we will bring the biggest element to its correct place, that will be this, in one whole traversal, or you can say in one whole iteration. So let me explain you the code once. Like we have one outer loop, okay, because we will be doing same operation for this container. Let me clear this once. Suppose we have this container, we will be doing one big traversal for this much of container. Okay, and you can easily say that there are n elements in the array. Okay, so in one iteration what we are doing is we are bringing one element to its correct position. So total number of iterations we need is, you can say that n, but this can be done in n minus 1 iteration also, because after all the elements n minus 1, when n minus 1 elements will be at its correct place, the last element will automatically get in its correct place. That's why we are doing only n minus 1 iterations here. Fine. Now in under loop, or you can say inner loop, inner for loop, what we will do is we will simply do the iteration. Suppose till now we have this much of array sorted. Okay, so now we will do iteration for this much of array only. Okay, and that is equals to j n minus I minus 1. Okay, j less than n minus I minus 1. So we are doing iteration for this much of array, and we will simply check that if two adjacent elements are not in correct order, we will simply swap them. So in this one iteration, what we are doing is we are bringing ith element at its correct place, and then we will do same for this much of array. Fine. So now we know what bubble sort is, and you can easily see the code and explain it to anyone. Fine. Now let's go towards insertion sort, and let me tell you again that since we are using two loops, two for loops, so time complexity will be obviously n square. That's why bubble sort time complexity is n square. Fine. Now we have insertion sort. and I have already explained you in brief what is insertion sort. In insertion sort, what we simply do is, suppose we have some container and we have some elements in it, okay, and we are at ith index. What we simply do is, we have to insert I at its correct position, okay. So we will iterate in this whole array from this position, okay, and we will simply check that all the elements which are bigger than this element, okay, suppose this element is x, okay, so all the elements during iteration from right to left which are bigger than x, we will swap them by one position, okay. Suppose we have some container and we are at this index x, and these elements are x plus 1 and x plus 2, okay, and this is simply x minus 1. So you can say that you have to insert x at this position, okay. So for that, what you need to do is, you have to bring x plus 1 and x plus 2 one position to the right. That means you have to do it in this way, x plus 1 and x plus 2. So you can say that all the elements bigger than current element x, you have shifted them by one position to the right. Same thing we are doing in this. We will do it for all the elements, okay. And suppose this is my key right now at the ith index, that you can say x, and index of just before element before then key, okay. So that will be obviously equals to j I minus 1, and we have taken that element in j, and now we will iterate from j towards left, okay. So that will be obviously j till greater than 0, and till my element at jth position is greater than my current key, okay. Same thing I have explained you, that till x is less than x plus 1 and x plus 2, and you are iterating towards left, what you will do is, simply you will swap all the elements to its right by one position, okay, and after every iteration you will decrease j by 1, and at the end what you will simply do is, you will put at this index your key. So you will make array of j plus 1 equals to key, okay. So this is also easy explanation of insertion sort. If you have any doubt, you can ask in comment section. I will again explain you in brief, okay. Now again we are using two loops here. One loop is for outer loop, time complexity is n, and for inner loop, okay, time complexity in worst case will be also n. When you are at, suppose when you are at index I is equals to n minus 1, you will be having j is equals to n minus 2 here, I minus 1, that is n minus 2, and suppose all the elements are greater than your key, so you have to iterate till 0th index. That's why time complexity is n square. Fine. Now our third sort, that is selection sort, and again I have already told you in brief about selection sort. Let me tell you, this is the easiest among all three, that is insertion and bubble and selection. What we do in this sorting algorithm is, suppose we have some container, as the name suggests, okay, just compare this whole algorithm with its name, okay, or relate this whole algorithm with its name. What we do is, we will select minimum element in this whole array, and we will place it at the starting position, okay. And now we will do the same thing for this much of array, that is from this index to this index, and again we will select minimum element in this range and we will place it to this position, okay. Now let me explain you. Suppose again I have already told you that we have to do the same operation n minus 1 times, because after n minus 1 operations the last remaining element will itself go to its correct position. That's why Now you have suppose that min index is right now I. Okay, now you will iterate from I plus 1 index up to j index. That is, suppose you are at current index this and you have to get minimum index for this, then you will iterate from this to this position. Okay, and you will just search for minimum element index. Okay, whenever you will get some value that is less than your minimum index, you will simply change your minimum index to j. Okay, and at the end of this loop, what you will simply do is you will swap this minimum index with current element. Okay, so what you have done in inner loop, you have simply iterated in whole array, you have searched for minimum element and you swapped this minimum element with your current position I. Okay, so as I have told you, this is your simplest among three. And now according to me, you have already known all these three algorithms, that are selection, insertion and bubble sort. And if you have any doubt, you can ask in comment section always. One more thing, if you haven't checked newtonschool.co website, and if you haven't checked pay after placement program and launchpad initiative, just come to their website and check both of these programs and get the most out of it. They are providing you free courses for everything under computer science, and you just need to come to their website and sign up for free. So just come and grab everything for free. And if you want to prepare for placement purposes and you want to get placed in some of good companies, so you can also check their pay after placement program, and I have already told you everything about it. And again, if you haven't subscribed this YouTube channel Code Kitchen Nutanix School, just subscribe this channel. I am posting one video every day so that we can complete our C++ and data structures as soon as possible. Now thank you guys for watching this video. Subscribe this channel Code Kitchen Nutanix School.